Hello and welcome to yet another video on Spec signals presented by your mentor Vivek. Here are three numbers from the same dataset and I want you to sit with them together. Teams with high AI adoption merged 98% more pull requests. The time taken to review a pull request went up by 91%. And team delivery, the thing the business actually measures, stayed flat. Nobody was slacking. The individual developers genuinely got faster. 21% more tasks completed. And at the end of it, the organization shipped the same amount. That is not a story about AI being bad at writing code. It is a story about where the work went when the writing got cheap. The paper that names this is called The Productivity Reliability Paradox by Sabry Farrag, posted to arXiv on the 1st of May this year. It is a multi-vocal literature review, meaning it pulls together 67 sources from 2022 through April 2026, both academic papers and industry reporting, and tries to work out why the evidence contradicts itself so badly. And the contradiction is stark. Controlled studies keep reporting productivity gains of 20 to 56% on well-scoped tasks, a carefully run randomized trial. This is the METR study, which we have referenced on this channel before, found experienced developers were 19% slower working on repositories they already knew well. And the large-scale telemetry shows a huge jump in output with no change in delivery. Now, the temptation is to pick the number that suits your argument. The point of the paper is that all three are real, and the job is to explain why they can all be true at once. His answer is that three variables decide which result you get: how well scoped the task is, how mature the code base is, a fresh project versus one you have lived inside for 5 years, and how experienced the developer is. Once you hold those three up against the studies, the contradiction mostly dissolves. The 56% gains come from well-scoped tasks in simple code bases, often with less experienced developers. The 19% slowdown comes from experienced developers in code bases where they already held the whole model in their head and where explaining it to an agent costs more than doing it. They were not measuring the same thing. They were measuring different corners of the same space. Then he names two mechanisms that amplify the problem. And this is where the episode gets useful. The first is the code review bottleneck, and the Farrag's AI telemetry is the clearest picture of it I have seen. Over 10,000 developers across more than 1,200 teams, 21% more tasks completed, 98% more pull requests merged, pull request size up 154%, review time up 91%, delivery flat. Read those together and the story writes itself. The work did not vanish when writing got cheap. It moved. It moved from the person typing to the person reviewing, and it arrived there in bigger, less familiar chunks, which is exactly the shape that is hardest to review well. The second amplifier is the context window constraint, and regular viewers will recognize this one immediately. The agent cannot hold your entire system in view, so it makes decisions that are locally sensible and do not compose. On the margin notes side of this channel, we have now watched 4 different authors walk into the same wall. One of them measured what it costs him in minutes. One tried to solve it by pasting everything into every prompt. One declared it solved, and the most recent one actually answered it architecturally by giving each phase its own context. It is genuinely encouraging to see it show up in a literature review as one of only two named amplifiers. It means this is not a quirk of one workflow, it is structural. Now, his conclusion and then the caveats, because this is spec signals and we do not hand out free passes. The sentence, "the whole paper is built to support," is this: specification discipline, not model capability, is the binding constraint on AI assisted software dependability. Read that carefully because it is a strong claim. He is saying that waiting for the next model will not fix the delivery problem, because the constraint is not how good the model is at writing code. It is how clearly the work was specified before the model started, and how reviewable what comes out is afterwards. And notice that this is precisely the argument I covered in Margin Notes episode 10 from a practitioner as an intuition. Here it is as the conclusion of a 67 source review. When an intuition and a literature review land in the same place, that is worth a moment of attention. And now the caveats, and there are real ones. This is an arXiv preprint by a single author. It is a literature review, which means it does not generate a single new measurement. It synthesizes other people's. The 19% slowdown is METR's finding, not his. The telemetry is Farrag's AI's, not his. What he contributes is the framework that makes them fit together and a governance model built on transaction cost economics. That framework is genuinely useful. But if you cite this paper, cite it for the synthesis and cite the original studies for the numbers. And the weakest part is the validation. He evaluates two instantiations of his governance model. One of them Spec hit through a 4-month pilot study. 4 months is short, and one pilot is small for a claim about the binding constraint on software dependability. So here is how I would file this. The paradox is well evidenced because the underlying studies are solid and independent of him. The explanation is plausible, and the three variables genuinely do reconcile the contradiction. The governance model is a hypothesis with a good mechanism behind it, and it has not been demonstrated at scale. Those are three different confidence levels, and they deserve three different amounts of your trust. So, what do you do on Monday? First, stop measuring the wrong end of the pipe. If your dashboard tracks pull requests merged or commits or lines written, then rolling out these tools will look like a triumph, because those numbers genuinely do go up by a lot. The two numbers that told the true story here were review time and pull request size, and almost nobody puts those on a dashboard. If you are running an adoption program and you are not tracking them, you have instrumented the half of the system that was never the problem. Second, the cheapest intervention in the whole data set. Pull request size went up 154%. That is the one variable in this list you can control directly today without buying anything or adopting any methodology. Constrain the size of the change. One task, one narrow patch, which incidentally is the same discipline that every practitioner article I have covered this month independently arrived at. If reviews are the bottleneck and the things arriving at the bottleneck have doubled in size, making them smaller is not a sophisticated intervention, but it is the one with the clearest mechanism. So, to summarize where I land, the paradox is well evidenced because it rests on independent studies rather than on this author's own data. The explanation, task scoping, code base maturity, developer experience is plausible and does real work reconciling the contradiction. The governance model on top is unproven and should be treated as a proposal. But the headline finding stands entirely on its own, and it is the thing I would want you to leave with. When writing code got cheap, the work moved to the person reviewing it, and most teams have not noticed because they are not measuring that end. All sources are linked in the description. Go and check my numbers. If you found this useful, please like, share, and subscribe. Thanks for patient listening, and see you in the next video. Until then, peace out.